3 years ago, humanity put into orbit the most powerful space observatory we have ever built, the James Webb. It was meant to do more than photograph distant glories. It was engineered to look so far back that its images would be echoes of the universe's childhood. No one expected what followed. Webb didn't only reveal infant galaxies and fledgling stars. It began to pry open contradictions in our cosmic story, structures, objects, and timelines that shouldn't exist, at least not yet. What began as a mission to map the distant past quietly turned into an unraveling of the universe's deepest assumptions. And it all pivots on one cold, unsettling conclusion: the universe may not be what we thought. When Webb trained its golden mirrors on the earliest reaches of space, astronomers expected chaotic, diffuse smudges, the ragged beginnings of galaxies still knitting themselves together. Instead, the telescope kept finding fully formed giants, massive, organized galaxies shining with a maturity that textbooks said was impossible so soon after the Big Bang. Some of these systems appear only 500 to 700 million years after the beginning, far too brief a window, cosmologically speaking, for gravity and time to sculpt such complexity. In other cases, the light is so intense the objects look older than they should. Hidden supermassive black holes could explain some of the excess brightness, but even with that correction the numbers don't line up. The result is a growing rewrite in the making, a set of serious question marks in the earliest chapters of cosmic evolution. Webb was built to collect data across wavelengths no previous observatory could reach, and those measurements keep revealing puzzles. Different techniques for gauging cosmic expansion, from Cepheid stars nearby to the relic glow of the cosmic microwave background, yield conflicting values for the Hubble constant. Webb's observations of remote galaxies deepen that discrepancy, creating what cosmologists call a tension that feels less like a measurement error and more like a fault line in our assumptions. Galaxies forming too rapidly. Stars that appear chemically mature far sooner than models allow. Vast regions showing coordinated motion where randomness should prevail. The more Webb sees, the less tidy the old models look. Planets, too, are surprising in ways that chip away at Earth-centric thinking. Webb's unprecedented exoplanet observations show worlds that strain credulity. Tidally locked planets with one hemisphere locked in endless dawn and the other in perpetual dusk, gas giants colder than expected, and puffy mini-worlds with tenuous, marshmallow-like atmospheres. Even more provocative are the hints of accessible habitability. Water vapor in the temperate zone of a young system, signs of volatile exchange on icy moons, auroral phenomena around objects that don't even orbit a star. Each discovery widens the range of places life might arise and forces us to reconsider how special, or common, life-bearing conditions really are. The telescope's greatest gift may be an unsettling awareness. The deeper Webb peers, the more it seems the cosmos answers back. Light bends around unseen mass in ways that suggest unseen structure. Gas filaments arrange themselves into patterns with an odd regularity. Magnetic fields and shock fronts trace rhythms and repetitions that whisper of underlying order rather than chaotic chance. In places like the Serpent Nebula, newborn stars align with a precision that looks guided. In the southern ring, concentric shells are ejected on a near-clock-like cadence. Researchers murmur about simulation metaphors and hidden algorithms, but Webb doesn't need to detect a spacecraft to make its point. The universe is composed of rules and recurring forms, and those forms sometimes look as if they were designed to be observed. Perhaps most disquieting are the stars that shouldn't exist at the times and places we find them. Webb has identified stars with heavy element signatures, iron, oxygen, and other products of long stellar life cycles, inside galaxies formed less than 400 million years after the Big Bang. Under standard theory, producing those elements requires generations of stars to live and die. Their presence so early suggests either extremely accelerated stellar evolution or a breakdown in our sense of cosmic chronology. Some theorists are even entertaining non-linear accounts of cosmic time. Loops, echoes, or folded history that could make later chemistry appear earlier. If those ideas hold any truth, Webb has not simply discovered new objects. It has exposed weaknesses in the temporal fabric of the universe itself. Dark matter, too, refuses to sit quietly. Webb's images show galaxies and clusters held together in ways that strain the simple cold dark matter picture. In some systems the invisible scaffolding appears to behave anomalously, steering baryonic matter in patterns that don't match simulations. Could dark matter have more complex interactions, multiple varieties, or properties that mimic agency? Or is our model missing a deeper mechanism entirely? Either way, Webb's data pushes beyond tidy metaphors of invisible glue and toward a stranger, more complex cosmic bookkeeping. On the largest scales, Webb's deep fields reveal coherence where only randomness was expected. Repeating arrangements, aligned spins across vast distances, and filaments stretching like arteries through space hint at a grand architecture, a cosmic lattice linking galaxies across billions of light-years. One feature, a curved chain of galaxies extending for over 3 billion light-years, is so precise in shape that it provokes the question: coincidence, or evidence of an underlying plan? If gravity and chance alone cannot account for such organization, we may be witnessing the contours of an unseen framework, the universe's floor plan coming into view. There is also a subtle edge to the observable universe, a region at which light behaves oddly and redshifts accelerate beyond simple expectations. Some theorists call it the cosmological horizon. Others speculate it might be a rendering limit, the boundary of what can be computed or displayed. Analogies to a graphical engine only loading what the observer can perceive are provocative, if speculative, but they force a hard thought. What if the cosmos has margins, places where physical laws fray or where observation itself collides with a deeper substrate? If Webb is scraping those margins, it may be revealing not just new astrophysics, but the architecture of reality. We built Webb to chart origins, to witness the birth of galaxies, to study stellar nurseries, to measure atmospheres on distant worlds. Along the way it has done that and more. It has revealed fractures in our narratives, fingerprints of unexpected order, and signs that the cosmos may be stranger, richer, and more responsive than we imagined. Whether those signs point to unknown physics, early, accelerated evolution, or something that resembles design, the consequence is the same: our assumptions are under revision. Webb's discoveries do not yet prove that the universe is an engineered stage or that something bigger watches us. But they do compel us to expand the palette of possibilities. The telescope doesn't merely show more. It forces us to look beneath the gas and light, beneath the distances and dates, and to confront the idea that our universe may be layered with structure and intention we do not yet understand. Perhaps the reason the heavens were silent for so long is that they were waiting until we built instruments capable of reading whatever messages the cosmos contains. So ask yourself, are we peering into a natural cosmos governed by blind chance, or into a system with rules and signs meant to be read? Webb is only beginning its work. If these findings unsettle you, you're in good company. This is the frontier the telescope has opened, scientific discovery that leads toward philosophical revolution.